It's time to spice things up and have a look at full stack web applications. We'll be discussing how the web has evolved, what is the front end, back end, and database, and different stack configurations. Grab your popcorn, the show's about to start. So first up, let's take a quick look at how the web has evolved. The web has evolved from simple text documents to sophisticated interactive experiences. The first websites were static web pages. They were incredibly simple and a bit of an eyesore. They came on the scene in the early 1990s. Early web pages were originally created by scientists to be able to share their work easily. You can still access the world's first web page, which was created at CERN. You can see it is fairly bare bones, with just some text and links to other pages. Fast forward to today, we have what we call full stack web applications, which is what you and I are used to interacting with, where the web application usually does something useful for us. Let's now take a deeper look at the web today. Web applications today blend advanced technologies to offer dynamic user experiences across a wide range of use cases. For example, there are e-commerce web applications like ASOS, where we can purchase clothing and get it delivered to our home. There are software as a service applications, shortened to SaaS, where the web application itself does something useful for us. For example, a tool like Canva can create digital social media posts, presentations, and more. There is social media like Facebook, slowly eroding humanity's sense of self-worth. And there are streaming services like Netflix. I married young, so never quite had the opportunity to use the phrase, "Do you want to Netflix and chill?" And now with young kids, Netflix and chill with my wife means let's watch Netflix and fall asleep. So let's now take a look at the web development stack. Most web applications today are full stack, combining front-end, back-end, and database technologies. At the top of the stack, we have the front end, which developers call the client. It is responsible for user interface and interactivity, and is what you and I are seeing in our browsers. The front end will interact with the back end, which developers call the server. The back end handles behind-the-scenes functionality. The back end then interacts with the database, which, as the name suggests, stores data. Now, in my opinion, getting a strong conceptual grasp of the web stack from the outset will help you a lot as you begin learning the details. It will give you a clear understanding of how everything fits into the larger context. Because I recognize the value of this, I've done a deep dive into this concept in this video and the next. We're going to move our way through the stack, starting at the bottom, the database. The database is a system for storing and managing data in an organized way. The database stores all kinds of data. It can store user data like names, emails, and passwords. It can store transactional data like items you've purchased. And it can also store product data like a product's name, description, and price. Now, it is possible just to have a database without a front end or back end involved. This is called a standalone database. The easiest way to understand this is by looking at a Google Sheet. While it is not strictly a standalone database, as it has a lot of features missing that are needed for a web application, it functions the same way, as you can store and manage data. For example, here is a fake contact list in Google Sheet I've made. I can add new records. I can edit records. And I can also delete records. I can also do basic data manipulation using Google Sheets interface, like sorting data A to Z. I'm going to be using a restaurant analogy as we build up the stack. The database is like a fridge. Just like the database stores different kinds of data, so too a fridge stores different kinds of products, like meat products, baked products, vegetables, and products you can fry. Moving up the stack, we get to the backend. The backend handles server-side logic, processing, user requests, and interacting with the database to retrieve, update, and store data. So we have our backend and database. One important function of the backend is to fetch specific data from the database. For example, the backend could have code that requests a weather database for all cities that are sunny and above 25 degrees. The backend would then get a response of, here are the 21 cities that match this criteria. So the backend retrieves data and processes it to fulfill specific requests. Now, the important thing to realize is that there is no front end here. There is no user like me and you in their browser asking for this information. This configuration of a backend and database is called an Application Programming Interface, or API for short. It's fairly hard to get your head around exactly what this is, as you and I are not interacting with APIs in our day-to-day life. But a lot of web applications are using APIs behind the scenes. For example, on Sky News there is a weather section. Sky News does not have its own meteorology department collecting data and forecasting the weather. Instead, they are using data provided by the Met Office. The Met Office make this data available through an API, which the developers at Sky News are automatically requesting weather data from. How this all works you don't need to worry about right now, and in fact in our course we will be developing our own API. The backend is like a kitchen, and we've already seen the database is a fridge. Chefs take ingredients and use recipes to make different dishes. Just like a backend will take data and process it to produce a desired outcome. This configuration in the real world would be a commercial kitchen. There are no customers sitting in a seating area at the front ordering food. Instead, food is being prepared for other retailers to sell. Let's now take a look at the front end. The front end is the user interface responsible for displaying content and managing user interactions. As we saw at the start, the front end is where user interactions happen. A common interaction we have on web applications is logging in. The request is sent to the backend. The backend will then need to work out if we can log this user in, like asking questions, is this the correct password? And it will need to check the database for these details. The database will send back the password, and the backend will approve the request or deny it if the password is incorrect. The backend will then send the user their dashboard. The interaction between the front end and backend is that the web page takes details and returns their dashboard. And the interaction between the backend and database is the backend checks details in the database and approves or denies. This is now our full stack web application, consisting of a front end, back end, and database. Just an important note at this point is that each of these components are totally independent from one another. We'll be looking in the next video about the actual coding and technology behind each of these, but keep in mind for now, they are 100% separate entities, to the extent in larger companies you will have distinct front end, back end, and database engineering roles. Back to our restaurant analogy. The front end is the seating area. It's where customers can request a meal with a waiter, in this specific case, a request of a cheeseburger with no pickles. The waiter will take this order to the kitchen, the back end, and the chef looks for the ingredients specific to the cheeseburger in the fridge, the database. The chef retrieves the ingredients, cooks them up in the kitchen, and will call the waiter when the meal is ready for the customer to eat. The interaction between the seating area and the kitchen is the waiter takes the order and delivers the meal. And the interaction between the kitchen and the fridge is the chef takes ingredients and makes the dish. This configuration gives us a fully fledged restaurant. So far, we've taken a bottom-up approach, building up from the database to the front end. We're now going to travel top-down to complete all the different types of configurations. Some websites are simple front ends, displaying content and information without complex back-end processing or data storage. Examples of these kinds of websites are things like simple personal portfolios of work, events like a wedding, or services like a plumber or lawyer, etc. A standalone front end is called a static site. For example, this is a personal portfolio of a dude called Fabrizio. He's the founder of this really cool tool called Coolers, which we'll be looking at later on in the course. I like his portfolio because it is so simple. It just has some text and links, but it is really impactful. Respect to you, Fabrizio. In our restaurant analogy, it would be like a display menu. Those menus on a stand, often outside more fancy restaurants. You can just look at the food, but can't order. We'll move a layer deeper now and look at the front end and back end together. Some web apps can process requests and deliver responses without storing any persistent data. On our front end, we'll have some kind of input, like perform this calculation. Our backend will perform this calculation and provide back the result to the user on the front end. So the front end takes instructions and sends back the processed request. This configuration is called a stateless application. There is no data being stored at any point. The web application is just performing some operation for us based on some input and criteria. One example of this would be a tool like Small PDF, which we use to convert file types. We can upload a document like a PDF and select the type of conversion we want, like a JPEG or PNG. The PDF would be sent to the backend for processing, and when complete, we get back our file without any data being stored. An analogy for this would be a coffee machine. There is the user interface where we select the type of coffee we want and provide input like the capsule and water. Our request for an espresso is passed to machinery inside the machine, which returns our freshly brewed coffee. Here, the user interface takes instructions and input to produce output. This configuration gives us a coffee machine. Let's now add to the summary card from the previous video. We've looked at full-stack web applications. We started at the bottom by looking at the database, which is a system for storing and managing data in an organized way. When used by itself, it is called a standalone database. We then looked at the backend, which is responsible for server-side logic, processing user requests, and interacting with the database to retrieve, update, and store data. A backend with a database is called an API. We then looked at the front end, which is the user interface responsible for displaying content and managing interactions. Combining the front end, back end, and database gives us a full-stack web application. We also saw a standalone front end is a static website, and a front end and back end is a stateless web app. Don't forget, you can download all the summary cards and presentation slides from the bootcamp in the link in the description below. Thanks for watching. I'm on a mission to create the absolute best web development videos here on YouTube. A single video takes hours of work between animation, image creation, scripting, and editing. As an independent creator, it means a lot to me to hear your feedback. So if you could show some love in the comments below, I'd really appreciate it. Also, click here to subscribe to the channel to get updates, and click here to move on to the next video in the Full Stack playlist.